No. Why can't we play the game? We literally got Maggie, and we didn't even get to play the game. We can't even figure out to drop the course. I don't know. Am I the only one who wants to be the most? You're the only one who wants to be the most. Well, I'm pretty sure it's harder than the homework makes it seem. So. Yes, but I wanted to play the Vigo game.
I will do it another day, I promise.
Yay!
Just like you promised to have us watch the video.
Okay, but when you can get them to load in here, I'm happy to. Yeah, I know. I know. Okay. Today, we are graphing square root functions and square root inequalities and then shading to show the solution set.
That sounds hard.
Your homework, I think, is
5
questions. I didn't think I made it super long. Oh gosh, no, you can do it all in one for sure. Okay, so we're going to start with just a base square root function. Which is y equals the square root of x. So this is what we call our parent function, if you remember anything about transformations. This is the base that we then add numbers into to change where it lies on the graph. If I'm graphing just a base square root function like this one, I'm going to use 3 primary points. The first one is when I plug in x equals 0, the square root of 0 is 0. When I plug in x equals 1, the square root of 1 is 1 for the purposes here. If I plug in 4, what's the square root of 4? 2. Why do I not want to use x values such as 2 or 3 or 5 or 6? Say it again, Keaton.
They don't have a square root.
They don't have a whole number square root. So my goal here is to plug in numbers that are going to give me a whole number answer. It's entirely possible for you to plug in, say, the square root of 2. Just know you're going to have to graph a decimal approximation, which makes it a little bit difficult. So we look for numbers that are going to give us nice, pretty whole numbers out as answers. So when I graph this.
Wait, so what? You plug in a number for y and then square root it for x?
No, we plugged in a number at x and square rooted it to get the y.
Oh.
So when I plugged in 4, the square root of 4 is 2.
Oh, okay.
Yeah.
What about 1 and 0?
Well, I did 1 and 0, but 4 was the bigger number. So we looked at that one. Okay, so if I'm graphing this, I put down 0, 0 first. Then I put down 1, 1. Then I put down 4, 2. So the graph of a square root function looks like this. It starts at that 0, 0 if it hasn't been moved at all. And then it goes to the right unless it gets flipped or transformed in some way, shape, or form.
Are we going to do that today?
Yes, we are. So glad you asked. Okay, from this graph, I can also identify my domain and my range, right? What x values did I use here or are on my graph? 0. Technically, I plugged in 0, 1, and 4, but anything to the right of 0 is covered by my graph, which means it has a corresponding x value. So that means that my domain goes from 0 to infinity. Then I go ahead and look at the range for this function, which means bottom to top. What's my lowest y value? 0. What's my highest y value? 2. It shows 2, but I have an arrow indicating it's going to keep rising. So we say it's infinity. So my range is 0 to infinity.
Is that only y value? Yeah.
Yeah, range is y values, domain is x values. Are we all okay with that? For the most part, for this graph. Okay. Yes.
Can you tell me one more time why it's the bracket and the parentheses?
Yes. It is a bracket on 0 because I'm actually hitting 0. It's a parentheses on infinity because we don't have a number for infinity. It's not a number we can actually reach because we can just keep adding 1 and it just keeps going. Okay. So that's something that, honestly, the more we do it, the more comfortable you're going to become with brackets and parentheses. But yes, that is why. If we actually reach the number, it is a hard bracket. If it is a number that we approach or approximate or we can't actually get to, like infinity, it is a parentheses. My pre-calc kids like to call it a hard shell taco and a soft shell taco. It's whatever works for you. Okay, so what we're going to do before we actually start graphing this is we're just going to practice finding the domain and the range of radical functions that have transformations that have happened to them. So they have other numbers in there. So we're just going to practice by finding domain and range. I'm just going to say D and R because we know what that is. The first function I'm going to look at is y equals the square root of x plus 4. So it was really, really easy before because I just had an x under my square root. Now it's a little bit different because I have a plus 4 that's also been put in there. What do I know about square roots and the kind of numbers I can take the square root of? Different question. What number can I not take the square root of?
Negative.
A negative number. X isn't a number, otherwise that would work. So I can only include numbers that when I plug it in are going to give me a positive or a 0 under that square root. So to find those numbers, I take what's under the square root and I set it so it's greater than or equal to 0 because I need that to be a positive or a 0 in there. Otherwise, I can't do it. And then I just solve for x. So I'm going to subtract the 4 across and I get that the x values I can plug in are any x value greater than or equal to 4. So in interval notation, we say that that's -4 to infinity. So that is my domain. And it is a hard bracket on the -4 because it is a double inequality. And then to find my range, unless there has been something added or subtracted outside of here, that would be a horizontal change, we assume our range is 0 to infinity. A way to check that is if I plug -4 in, what do I get? 0. And the square root of 0 is still 0. So any number I plug in after -4 is going to give me a number bigger than 0 as my answer. So my range is still 0 to infinity. We're going to go ahead and change it up by doing another function now. This function is the square root of x minus 2. I know when I'm looking at the domain, I'm trying to think of numbers that I cannot plug into that, and I know I can't take the square root of a negative number. So I have to take what's inside of here and set it greater than or equal to 0, and that tells me my domain. I didn't have any other numbers with it, so I'm just left with x greater than or equal to 0. So my domain is 0 to infinity here because I had no horizontal shifts. What about my range? What do we think that's going to be? 0 is the smallest x value I can plug in, correct? So what do I get when I plug 0 into that function? I get the square root of 0 is 0, minus 2 is -2. So -2 has to be the smallest y value that I'm going to have, which means that my range goes from -2 to infinity. Are we kind of seeing what's happening here? If we add or subtract a number inside of the radical, it changes my domain. If we add or subtract a number outside of the radical, it changes my range. Okay, so let's go ahead and do another one just, for super fun practice.
Homework?
No, we haven't even graphed yet, man. Don't even. So I get y equals the square root of x plus 3 minus 1.
Is this what's going to be like a homework?
Maybe, maybe not.
You're going to be like one that's on homework.
Did you say I'm an evil lady?
Oh
my gosh. That's the first time I've ever been called evil.
No. No, like the way you say like maybe.
Oh.
Maybe
I
not.
like to leave you guessing. It's fun.
They say is it really? No.
This is a math class. We shouldn't be guessing in here.
That's true. You shouldn't.
Should be approximate.
Unless
But you're making-
You should be making educated approximations. That's what we should be doing.
You just
Uh,
cleared your board.
You
No
just put
math.
ha that. Yay.
the video.
That's great. Amidai. I would like to find the domain first. What am I going to do?
X plus 3 0.
Equal to 0 or greater than or
greater
equal?
or
Good. X plus 3 greater than or equal to 0 because I need what's under that radical to be positive or 0. And then I solve for x. So I get x greater than or equal to -3. So then I can go ahead and write my domain as -3 to infinity. Are we all okay with that? Sometimes we'll have negative infinity if it's been flipped. That doesn't happen very often. More often than not, we'll have it flipped over the x-axis, not the y-axis. Okay. So now I would like to do the range. Does anybody have an educated guess about what that range is going to be, Brandon?
Negative 1
How did you get -1 to infinity?
because you took the -3, plugged in for x, and then that made it 0. And then 0 times 0, square root of 0 is 0. You minus 1.
Perfect. So that vertical shift right there says that I took my origin and I just dropped it down 1, which means that instead of going from 0 to infinity, I'm now going from -1 to infinity. So that is entirely perfect. So the range here is going to be -1 to infinity. The way Brandon explained it was flawless. I took the smallest x value I could get, I plugged it in, and I solved. The answer I got was the lowest y value that I could get. Are we all okay with that? Anybody have issues with domain and range of a radical function given to you like this? Questions, concerns, or issues on it? Yes.
Is it always the number outside of the square root?
For the range?
Yeah.
Yes. Yes. Okay, so let's take all of this that we have just done and rewrite it in terms of transformations that have happened, just to kind of refresh our brains about transformations and what they are. Because I know you miss them oh so much. That's why we just keep revisiting them.
I have that paper.
Did we do transformations over like when we were gone for 2 weeks?
No, that was when
I know
she
you guys
was
did them
gone.
when I was gone.
Oh, that's why I don't know.
Yeah.
Okay. Let's say that we have a radical function that is y equals some constant a times the square root of x minus h, all plus k. Okay, this a, h, and k represent different transformations that happened to my parent function, which is just y equals the square root of x. Okay?
Why do you have to? It's confusing. Can I plug in y right there?
Yeah, it's the same thing. This just means functions in terms of x, which is how we talk about this stuff sometimes. Okay, so let's just identify what these are. The first one, A, is a vertical stretch or shrink. Which means it takes that range or the height of my function and either makes it shorter or taller, depending on if it's a stretch or a shrink. It behaves exactly as we think it should. So if A is 2, that's a vertical stretch by 2. If A is 1/2, that is a vertical shrink by 1/2, or compression, depending on what you like to call it.
We just have to be a negative to shrink it.
No, has to be a number less than 1 but greater than 0.
Okay.
If it's a negative, because this is something awesome that often gets confused, if that A value is negative, so it's like -3, that indicates that I had both a transformation and a reflection. So an A value less than 0 indicates that I had a reflection over the x-axis. Which often means that instead of going from 0 to infinity for my range, I would go from some number to -infinity. So it just means my whole graph flipped over and is going to grow in the downward direction instead of the upward direction. Next thing I'm going to identify is my H. So that H value right there is a horizontal shift. Horizontal behaves the opposite of what we think it should. So for example, if I have the square root of x minus 4, that is a shift right 4 units. If I'm taking the square root of x plus 4, that is a shift left 4 units. So it goes the opposite direction. If I'm subtracting a number, I'm moving right. If I am adding a number, I'm moving left. And yes, bold, sorry.
Can we do this?
Yes, we've done this before. Now we're just attributing it to radical functions.
I remember that part, but I didn't remember.
Our last little transformation that we can have occur on a radical function is that k outside. This k is a vertical shift, so up or down. It moves exactly how we think it should. So if I'm taking the square root of x and I'm adding 2, that indicates I moved up 2. If I have the square root of x and I'm subtracting 2, that indicates that I moved down 2. Those shifts, so the horizontal and the vertical, should be somewhere in your brain. Those are the most common types of transformations that we have. And I know you spent longer working on those than any of the others. So what we have now is we have about 4 examples and then we're done. I know you're so excited.
Yeah, the graphs is going to take like 6 weeks.
I did it all on this.
My graphs are massive. I don't understand how you use those.
How are your graphs so pretty?
They're not.
They look like
Oh, thank you. I freehand them laying on my bed. So yes, whatever it turns out to be.
Drawing
I
your
was just destroying it.
So I lay down. I write. It takes me hours to write all my notes for a day. Because I have 5 different classes that I write notes for. So if it takes you 45 minutes to learn it, it takes me an hour to write them. Pretty much guaranteed.
I wouldn't put that much effort.
So much fun. Okay.
You have fun
So
doing
what
that?
you're saying is, if you made our lessons easier, it would give you more time.
So
Maybe. Yes.
Wouldn't that
I'm
make
still not
sense?
going to do it.
we should give Duran a break then. She deserves it.
We would also get a break.
You would, and I'm not sure we could do that.
We just want to show up to classes. Miss Brian, we can tell you're stressed. That's why you need to do your daily yay, not this fun, because you need to let your brain know that it's happy.
What makes you think my brain is not happy doing math?
Because
Because who does?
Because when you get home, you have to lay in bed for 5 hours writing the notes. Not doing what
It's not when I get home. I get to play with my daughter first. That counts.
I know. That kid.
I remember the little sheet of paper that we got.
Yeah, I still have mine.
Yeah, we should still have it. If not, I can print off
Is
more.
it?
But the sub should have printed a nice little piece of paper for you that has all the transformation stuff
Oh,
on
I
it.
Was
definitely
this
don't
when you
have
were
that.
gone?
I
Yeah,
said-
print some more.
Oh yeah, I definitely. do.
Yeah, no, I.
Yeah, it was when I was gone. That's when I had her print it for you. I never would have done that in class.
They all must really be personal.
Okay, so the function I have in front of me is y equals the square root of x minus 2 plus 5. I would like to graph this and identify my domain and range. Do I have to graph it to identify my domain and range? No, we've already done it without a graph. So let's go ahead and identify that first. How do I find the domain of my function? Sarah?
Oh, wait, you do.
I have to do something with the x minus 2 that's under my radical. Right? Because whatever number I get there can never be negative. So what do I have to set that equal or greater than, Sarah? To 0, yeah. So I'm going to take that x minus 2 and I'm going to set it greater than or equal to 0. And I'm going to solve for x. And when I do, I get x is greater than or equal to 2, which means my domain goes from 2 to infinity. Everyone okay there?
Yes.
How about my range?
It's a +5.
So say it again, everybody. What's my range?
6.
5 to infinity. Because if I plug 2 into this function, I get 2 minus 2 is 0. The square root of 0 is 0 plus 5 is 5, which means the lowest y value I have is 5. Are we all okay there?
Yeah, now it's graph.
Now let's graph it. Okay, so in order to graph it, I need to have 3 beautiful points, which means I'm looking for whole number answers.
0, 0.
What happens if I plug 0 into that function? 0 is not part of my domain.
You're gonna get a negative.
So what I'm going to start with is 2, because you told me that that's the smallest x value I can have here. So we're going to start by plugging in 2. What do I get when I plug in 2?
5.
5. So the first number of my domain is in fact a pair with the first number of my range. So 2, 5 is the first point that I will be able to put down. Yes.
Well, if you take those two numbers, will it always be a point?
Yes.
Wait, what did you plug in? 5? Or what did you plug in?
I plugged the 2 in. I got 2 minus 2 is 0.
Oh.
Then plus 5 is 5. Are we okay with identifying the first number of my domain and the first number of my range are the point I'm going to start with? Because it literally means I took my origin and I shifted it somewhere. We just had to find where we shifted it to. So that's 1 point. I need 2 more. And I'm looking for numbers that are going to give me beautiful, beautiful whole number answers. Because if not, I don't want to do it. How did you come up with 3? Whoever said it.
Because if you subtract 2 from 3, you'll get 1.
Correct. So if I plug 3 into this, I'm going to get 3 minus 2 is 1, and I know the square root of 1. What is it? 1. So when I add 5 to it,
6.
I get 6. So 3, 6 is the next point I'm going to put down.
Oh, this is not at all how I thought we were supposed to do this at all.
And then I need to find 1 more.
6.
How'd you come up with 6?
4.
What happens if I do 4? I'm going to have 4 minus 2 is 2. What's the square root of 2? Nothing pretty.
So
So I agree with the 6. So because if I do 6 minus 2, I get 4. The square root of 4 is 2 plus 5 is 7. So 6, 7 is my next point. A lot of times we have issues finding those points, and that's okay. I'm going to show you a shortcut on how to find them. Yes, ma'am.
Can you explain that 7 like 1 second again, because I was trying to process.
Yeah, I took the 6 and I plugged it in.
Yeah.
6 minus 2 is 4. What's the square root of 4? Plus 5 is 7. If you don't know what values to plug in, we can find them. In my original function, I plugged in 0, 1, and 4, right? Because they're beautiful, beautiful numbers that give me whole number square roots. Do you remember that?
No.
Okay, so that was on my parent function. Because I have shifted it, that means different numbers are going to be used. So what I can do is I can take this piece that's under the radical, and I can set each of these equal to that, and it's going to help me find the numbers that I can plug in.
Wait, where'd you get the number?
0, 1, and 4 are the defaults. If we just have the square root of x, those are the numbers I plugged in. Those are the ones I did on the very beginning.
They're all related.
Because I did 0, 1, and 4. Because when I take the square root of those, they come out to whole numbers. So 0, 1, and 4 are always the ideal numbers that we look for. So what we can do is I can take 0, 1, and 4, and I can take whatever's under the radical and set it equal to those numbers, and I can solve for x then. So for example, when I have 0 equals x minus 2, I would add the 2 over, and I would get 2 equals x. Guess what? The first x value I had was 2. I do the same thing here. I add the 2 over, and I get x equals 3. Hey, look, that's the second one we already did. Same thing on the 4. I add the 2 over, and I get x equals 6. Wanna bet that's the third point that we found. So by setting what's under the radical equal to 0, 1, and 4 and solving, it tells me the x values I will be plotting for my specific radical.
So how do you figure out the y then?
We just plug these numbers into this and solve.
Put 2 into it.
Yeah, if I plug 2 in, I get 2 minus 2 is 0, plus 5 gives me 5.
Okay.
Does that kind of help any of you who are lost on how to find those? Okay, so we always want to set them equal to 0, 1, and 4 because they're the smallest perfect squares. Okay? So now that I have those, I can go ahead and I can graph this function, which is just graphing like normal. I go to 2, 5. I go to 3, 6. And I go to 6, 7. My function in my graph starts at that first point. There's nothing to the left there. That is what my graph looks like. Kind of floating. Huh? Does that kind of make sense?
Well, we have like an example where like domain does go to like negative.
Not domain, but range. And I will show you one of those. Yeah. There's not one on your homework, though.
Is there on the fraction?
You never know. So how do you not do a fraction? Okay, any questions, concerns? Does this make sense after we see a work through example? Is anybody confused about any portion of this?
No, I think
Yes, both.
I was just confused why you showed the 0, 1, 4. Like, I understand that's perfect, but like, does that have
No, I was showing a way if they couldn't figure out the numbers just freehand, how to find them. So you guys free thinking found these. I just showed that it works setting it equal to those as well. Because sometimes it's not as easy to visualize what the number is. So it's just an alternate way of finding those. Let's do another one. Because, you know, we definitely should. Your homework is primarily domain, range, and then graphing these, and then there's one inequality question, and that's it. Okay. So the next function I have is y equals the square root of x plus 3 minus 1. We're going to start with domain and range, and then we will graph it. On your own, I'd like you to find the domain and range.
Doing this all the time is getting good, making me get good at doing infinities.
Yeah, I'm telling you. That's why I can always tell when somebody's new to it because they'll turn the paper sideways and they'll do like the 8. But once you get used to it, you just draw it. Reese, what's my domain?
-3.
Perfect. -3 to infinity. Show of hands, who else had that for your domain? Perfect. Range. Oh, who should I call? Xavier, what's my range? -1 to infinity. Show of hands, who agrees with that? You definitely should. That is 100% correct. Which means the first point that I'm going to be graphing is what? -3, -1. Good. We can obviously check that by taking what's under my radical and setting it equal to 0. And then I subtract the 3 over, and I get x equals -3 is the first x value I should check, and it worked because it's the first one that we already found. To find my other 2 points, I set x plus 3 equal to 1 and x plus 3 equal to 4. I solve for x, and I get x equals -2 and x equals 1. Everyone okay with that? We just need 3 points. I know, I'm going to pause. I'm pausing right here.
I was trying to.
Yeah, me too. I sometimes get a little carried away in my enthusiasm, so I need to slow it down sometimes.
No, just plug it in.
Now you just plug them in. And we'll plug them into this function, and then we will solve. Shane, what'd you get for -2? What's the y value?
I got 0.
You got 0. That's perfect. Because negative 2 plus 3 is 1. The square root of 1 is 1. Minus 1 is 0. Miranda, what about 1? Okay, I'll give you a second. Nope, no problem. One, yes.
Wait.
I got 3.
1 plus 3 is 4. The square root of 4 is 2. Minus 1 is 1.
I'm gonna miss that, right?
And then we just go ahead and we graph
Say that
it.
again.
Huh?
Say that again. How did you go 1?
1 plus 3 is 4. The square root of 4 is 2. Minus 1 is 1.
Oh.
Felt like you were about to make fun of me for something. I didn't know what it was.
Every time.
You know what? You need to. So I plot my points. I have negative 3, negative 1 first. Then I have negative 2, 0. And then I have 1, 1. I go ahead and I draw my graph. And I'm finished.
So you know which direction?
It always goes to the right. Always goes to the right. It doesn't. Because it won't. It never will. Because that's assuming that, yeah, no, it just won't. We don't have one that goes down. At least not very often. It is possible. I'm not saying it's not possible. We just won't have one that does that. Okay, we're going to do one more graphing, and then we'll try to fit an inequality one in. I can't guarantee it's going to happen, so that might be tomorrow.
So 4 questions.
So 4 questions on the homework if we don't get to the inequality one, which is almost identical to these. I'm just going to say it. Okay, so the last one that we're going to do just for normal graphing is y equals the negative of the square root of x minus 5.
It's okay, I just did. It just when you.
What is that one on top?
That's from the thing above, sorry.
Oh, okay.
Okay, so we need to go ahead and figure out our domain and our range. Domain works exactly the same as it did previously, right? How do I find that domain?
We do x minus 5 and then the little thing above.
Greater than or equal to 0, and we solve. And we get what? 5 to infinity. Perfect. The range then is going to be the opposite. So I can do exactly what I did before. I take 5 and I plug it in. And I get 5 minus 5 is 0. So I know that my range has 0 in it. But instead of going to positive infinity, it's now going to go to negative infinity. Because I'm taking every answer I get and I'm multiplying it by the negative 1. So my range is 0 to negative infinity, which actually is incorrect because we go smallest to largest. So it should be written negative infinity to 0. This is how it should be written. If you did 0 to negative infinity, I probably wouldn't count it wrong. Probably. I can't make any promises, but probably.
No, shoot.
So just like before, I need to find 3 points, and I need to graph it. What's the first point I'm going to use? 5, 0. Good. Then to find the other 2, I take the x minus 5, and I can set it equal to 1 and equal to 4. And I just go ahead and solve. Once I get my x values, I go ahead and I plug those in, and it will give me the correlating y value. Oh, excuse me.
Is that a
Yeah. In front of me, I'm dying.
Sorry.
It's okay.
It's just so easy.
I know. Okay. Okay, so when I plugged this in, I got 6 as one of my x values. When I plugged it in, I got negative 1. Then I got 9 as my other x value. When I plugged it in, I got -2. Who else has these 3 points on their paper that they found? Is anybody confused by how I found those 3 points? Okay, so now we just graph it and we're done. My first point was 5, 0. My second point is 6, -1. And my third point is 9, -2. So I go ahead and I draw my graph through those 3 points. How do we feel about that? Okay. Any questions, concerns, or issues on graphing radical equations? And finding domain and range, because that's a huge part of it. Okay, so we do actually have time to fit in this inequality question or inequality example, and then you're good to go on your homework. And as I said, majority of the process for the inequality one is exactly the same as this one.
Wait, Miss Serena, I have a question.
Yes, ma'am.
For like the defaults that
Yes.
go on the side, it's x minus 5 equals 1, and then the one we did before was x minus 2. Do we just like plug in the number that's in the radical?
Yeah, we literally take what's under the radical, and that's what we set equal to that stuff.
Oh, okay.
So because this one was x minus 5, I used x minus 5. The previous one was x minus 2, or whatever it was. So we just take what's under that radical and set it equal to those 3 numbers. Okay, so this last example for today, I know you're so excited, is to graph the inequality. And the inequality we're using is y is less than the square root of x plus 4 minus 6. Just as a practice, I would also like to find the domain and range for this function. It never hurts to do more of those. Okay, so we're of course going to go ahead and we're going to start with our domain.
Would it be like -4?
Yep, -4 to infinity. The only difference here is that I have an inequality, so I'm not actually going to use a hard bracket because it says less than that in radical. So it's going to be soft bracket, -4 to infinity. So because I had a single inequality, my domain and range will also only have parentheses, no hard brackets on them.
Is that all inequalities?
Only if it's a single inequality. If it's a double, it's still a hard bracket. So then my range is going to be what? -6 to infinity, yes. Again, both of those parenthesized, soft shell tacoed, soft bracket, whatever you want to call it. Questions, concerns, or issues with domain and range for an inequality? Okay, so now I want to graph it, which means I need to have my 3 points. Shane, you already identified the first one. What is it? -4, -6, right? Yeah. Finding these points works the exact same as it did before. So I'm going to take that x plus 4 that's under my square root, and I'm going to set it equal to 1 and to 4, because those are the only ones I haven't used yet. I go ahead and I solve then. And I get x equals -3 and x equals 0. And then I plug those numbers into my inequality. And when I do, I get -3, -5, and 0, -4 as my points. Anybody not get those points? Okay, so now I'm just going to graph this like normal, except for one difference. What is that difference going to be? Nope.
The dotted line.
Am I using a dotted line or a solid line? Dotted because it's a single inequality. So that means when I go to graph this, it's not going to be a solid curve. So I go ahead and I draw my plane. I plot my points. So I have -4, -6. I have -3, -5. And I have 0, -4. I go ahead and I draw my dotted line as best as I possibly can. She isn't pretty, but she works. And then comes the shading portion. How did I shade on inequalities before? What did I do first?
Both equal to 0.
Plugged in 0 for x and y. So I picked a point on my graph. I plugged it in. If the inequality left is true, I shade toward that point. If the inequality left is false, I shade away from it. I like to use 0, 0 when my equation or inequality doesn't go through it because it's a really easy one to plug in. So that's what I'm going to use here. So when I plug in 0, 0, I get 0 is less than the square root of 0 plus 4 minus 6. I simplify that out. And I get 0 is less than -4. Is that true? No. So instead of shading the top or above this dotted line, I'm going to shade underneath. But we only shade the domain. So my shading can only go from -4 to infinity. So I'm going to shade all of this. I can't go to the left of where my graph starts because that's not part of my domain. And then we're done. How bad was that? Not terrible? Not the worst lesson I've ever given you?
You probably would have gave us like piecewise whenever you're here. Oh man, that would
The only thing about it
We will revisit piecewise. I love piecewise.
You don't need to do that.
No,
actually, I do.
Okay, so your homework is on Canvas. It is 5 questions. 4 of them are graphing your own, and one of them is kind of you do it. Will you do it kind of thing? You make it up kind of thing. I love this. Okay.
Is there graphic? I spotted it.
There's some in like that box. I'm not actually sure where it came from, but you're more than welcome to use all of it. Okay, so those of you kiddos online, if you have questions, obviously let me know, but your homework is on Canvas. It is 5 questions, and it is due tomorrow.